Today I'm going to show you how to make a Joule piece. It's an extremely simple circuit and only takes a small number of components to make one. To build your very own Joule piece you'll need a toroidal inductance coil or toroidal transformer, a 1K or 1000 ohm resistor, 1 NPN transistor. I'm using a BC549C, but almost any NPN transistor will work with this circuit. 1 LED or any number of LEDs you want to power. I'm using 4, and obviously a dead or nearly dead AA cell battery. The most important part of this circuit by far is the coil. I've already made a video on how to make a toroidal inductor coil or toroidal transformer, so I won't demonstrate that now, but that video shows you exactly how to make them and gives you an explanation of how they work. Tells you some places where you can get the ferrite rings or ferrite toroids from, and how to use them to change voltages, either to step up voltage or to step down voltage, and how to calculate the ratios for your winding to do either of those, to either step up or step down the voltage. A link to that video is in the description. So let's tear this Joule Thief circuit down and I'll explain exactly step by step how to make it. I'm using a breadboard for this demonstration because it's better for all of us. I don't have to do any soldering, and that means that the video will be shorter for you guys. First off, we need to get our multimeters out and we need to set them to continuity testing mode. So I shall do now. And we're going to test our coil. What we're trying to do is we're trying to find 2 wires on the coil, one from either side, which do not show continuity. This is because we want to put a centre tap in the coil. Well, basically a centre tap is joining the 2 windings up at the centre point of the coil. So I'll get the positive and negative probes and we will just test. So if we hear a beep, we know we've got it wrong. Okay. So it's not those 2, so we could either do so I'm going to pick those 2 for this demonstration. Okay, so we pick those 2 wires. So we would either solder those together or twist them together. However, because I'm using a breadboard, I don't need to do that. I'm going to end up putting both of those wires into column 1 of this breadboard. So into column 1, there you go, like so. Then I'm going to miss a column, and we're going to put one of the other wires into column 3. Ever so fiddly this, but we'll get there. Column 3 and the other one into column 4. I don't know how well this will show up on the video, but into column 4, like that. So we've now got all 4 wires from our toroidal transformer connected to the breadboard. We've got 2 that didn't show continuity connected to column 1, and then the other 2 we've got 1 wire in column 3 and 1 wire in column 4. That's our coil all connected up to the breadboard and finished with. Next we're going to add our 1K resistor, and that is going to go in column 3. And I'm going to use the 1K resistor to bridge the top half and the bottom half of the breadboard. On column 3. There we go, like so. And then I'm going to use a jumper wire to bridge the top half and the bottom half of the breadboard in column 4. like that. So we've got 2 from the coil in column 1, 1 from the coil in column 3, resistor in column 3, 1 from the coil in column 4. We've bridged the top half and the bottom half of the breadboard, one with the on column 2 with the resistor, column 4 with a jumper wire. Next comes our transistor. On this transistor, the left pin is the collector, the middle pin is the base, and the right pin is the emitter. Now, if you're using a transistor that you've taken from some old or broken electronics, you need to test the transistor. Most multimeters have a transistor tester on them nowadays. Certainly mine does, and it was only cheap. It was less than £10 from Amazon. And B, you'll need to find a data sheet for the transistor that you're using, so that you know which pin is the collector, which is the base, and which is the emitter. Most transistors will have the middle pin as the base, but this isn't always the case. So just type in the part number of the transistor you're using into Google, followed by the words transistor and data sheet, and you should be able to find what you're looking for fairly quickly. For example, I type in BC549C transistor data sheet, and it would show up fairly near the top of the search results. We're going to put the transistor into the breadboard now, and we're going to put the base, the middle pin, into column 3. That means the emitter is in column 4 and the collector is in column 2. So now connect up our power source, our battery. This is just a AA, and all I've done is sellotape 2 wires onto it so that I don't have to mess about holding the wires on for this demonstration. Okay, so the positive is going to go into column 1 in the top half of the breadboard, and the negative is going to go into column 2 in the bottom half of the breadboard. So that's our power source all connected up now. Next, let's shine some light onto our Joule Freeze project and add some LEDs. The positive terminal, or the anode of our LEDs, will be put into column 4 and the cathode into column 2. And as you put the LEDs in, you'll see they will light up. So you don't have to stop at one LED, you can carry on going. Now obviously there wouldn't be enough power in that battery, there wouldn't be enough voltage to light these LEDs under normal circumstances, which is exactly why this Joule Freeze circuit can be quite useful. We've got 3 in there so far, and I can fit 1 more in, so I will put 1 more in. There we go, that's 4 LEDs running off 1 AA cell battery, and it's a dead rechargeable AA cell battery, so even if it was fully charged it would only hold 1.2, 1.3 volts. I don't think I've charged that for about a year, and it's been in my television remote, so it's going to be fairly dead. I haven't checked the voltage of it, but it is going to be fairly dead. So a Joule Freeze circuit that anybody can make. Just watch my other video on how to make the toroidal coil. Please subscribe and hit the bell for notifications to my newest video, and remember to hit the like button if you like this video. Thanks for watching, and I'll see you again soon.